Okay, looks like we are complete. Can start the session. Could we go back to yesterday? Go back. So, diff, you can basically show an example for diff. We use this command to compare text files, displays two files between and differences between them. So, if you work with code bases before, diff kind of acts like when you're doing a pull request, and let's say there are two developers working on one file, and basically it won't be identical as one person would add some stuff and the other person might add or remove stuff. So they also use these lines in um, source code management, or let's say in GitHub. Diff is similar to this one. So in my VirtualBox, um, I have created this simple text. It's called "Hello World." This is Clark, and today is dot dot dot. The other text that I have is "Hello World." This is Jason. Tomorrow is dot dot dot. So I can use the diff command and supply it with two arguments with two text files. And as you can see, this is Clark, comes from the first file. It is denoted by the less than symbol. And the other one is this is Jason, denoted by greater than symbol. And then the next line that is, as you can see, it says here which one, right? It's the third line, this is the fifth line. Today is dot dot dot, and tomorrow is dot dot dot. So let me see if I can quickly grab an example online. See. Let's see. What was that again? Let's see if I can look at some of the ones that I did before, or let's just look at code bases. Let's see. How do I check this again? So in GitHub, it will also show you minus and plus. But there should be a better way to show it. Um, I'll just Google it. It's easier because you have to make those conflicts. Conflicts in GitHub. Because it basically uses kind of the same notation. I think this one is a good one. Yeah, as you can see, this is coming from, let's say, the previous one. This is coming from the new one. So first file, second file, less than, greater than, something like that. No, let's have a conflict. Maybe this one. What this one? Oh, this one. There we go. So kind of like that as well. It shows you, I think this is a good example. It shows you that from the head, just think about this as your first file. In your first file, it has the debug.writeLine. In the second file, that's trying to merge it, and in the same line, it's basically trying to say, oh, I don't want the debug.writeLine x dot message. I want the debug.writeLine x dot inner exception. So they are separated by this line, right? And there's the less than and the greater than, right? Now, what you usually want to do is resolve these, and you can add both. You can remove the bottom, or you can remove the top. So that's how you resolve conflicts from two different versions of a file, something like that, or two files trying to merge as one. Okay. Let's see. And then again, going back, this is like that. Let's see. Difference by line number, files being compared. So when we look at this one, everything's just, would say, addition, I guess. So let's try to simulate something like that. So let's create a text called e1.txt, and let's put here, I don't know. Okay, and write that. And let's create another one called e2. And let's put hey yo. Let's now try to use the div. Yep, as you can see, first file has this, the second file has those, right? And let's see if we can merge them together. Merge div. Basically just to put a redirection. Oh, sorry, it should be E2. We were trying to compare. Oops. We were trying to compare E2. D, E1, E2. Yep, yep. And then let's say we want to create a file called C. So it basically includes all of those. Let's see. I want to try I saw something. Unified format. Let's see. Let's try that. One, two, three. So unified format allows you to have the plus and minus instead. Good to know. Can we merge them in one of the two also? Yes. So later on, I think you'd see that we would append stuff with the greater than symbol. Oh, where were we? Sorry. Why did I click that? Okay, grep. Grep is your best friend and should be your best friend. It's basically a search tool, and it's not limited to finding file names. Often used to search contents of files as well. Output displays each line of file that matches your provided search pattern. The clue here, it will display the line. So not everything, not just the word, but the line. Okay, you can process and read contents pertinent to you. Example, retrieve login events of specific users. You don't need to read the entire file. You don't need to step through a text search to it in a text editor. Use grep to print all of the relevant lines. Let's try to do some examples here. Let me just remove this one. So let's say I have something like this, which I basically have some stuff like a title separated by spaces, URL, and some details. Let's say I want to find a specific topic. I do grep, let's say merge, and I supply it with my file name, and we get something like this. It highlights that. In some cases, you don't have it highlighted right away. For me, I just basically create an alias that has something like this, color auto, or you can do color always, something like that. Because with the normal grep, it might not do some highlighting. It will just be white text all throughout. So that's one of it. Let's see first before we give more example. Yes, you can search for term. This is what we did. Search for the term inside the file. And let's see what we can do with other grep commands. Let's see. Grep examples. And grep can be basically used with regular expressions, which we might do later instead. So you can also search for case insensitive. So if I go back here, if I do a lowercase m, as you can see, it highlighted those at the end. It did not really found the uppercase m. So we can supply that with a dash I to ignore the case. And now it would find both of them. Let's see. Regex later. Yep. You can also display, I think, the lines. Let's see. Okay, how about something like, oops, invalid argument, sorry. Supply with a number. One, two, three, four. How about if it's 1? Let me check again. What's the difference with that? Print num lines of trailing context after each match. How about C? Normalize trailing context after each match. Maybe that's not a good option to show. Let's see. Ignore case. Very important for sure. Files with matches. Line number. I think line number is important as well. Yep, so this helps you check which line you are in the document. See, highlighting. Okay, position that match in the line. Okay, so we'll move on first and talk about regex later. First, another one is the awk command. Why is it called awk again? Pattern directed scanning and processing language. It doesn't really say why awk. It basically performs pattern matching on files based on the awk programming language. With that alone, you can basically do loops, stuff like that. Keyword is followed by pattern, action to perform, and file name. Action is placed in curly braces. Pattern and action should be inside single quotes. This can be used from command line or executed as a script. Can process files in a variety of ways. Retrieve text matching pattern, delete text matching pattern, and add text matching pattern, and much more. So as you can see, this one, it says awk, and then the $1 equals gen, so that's what we want to search for, and this is the file that we want to look at. Let's show some examples of awk. Very first thing we can do, it's not here. Use my terminal instead. It's easier. So with awk, you can call the print function. It should be inside of single quotes and curly braces. And then now you would like to supply it the file name. So this kind of acts like the concatenate. It just prints out the standard output to your command line interface. If you do want to do pattern matching, you basically add inside the single quotes, would have 2 forward slashes. And now you would like to, let's say, find merge. And it will print out those lines as well. Let's say you want to split the lines into fields. Let's say I want this, let's say, field or column, and the third field or column, so which is separated by spaces. So I would do something like inside the print statement, I would put $1 and say 3. And as you can see, it printed the first field or column and the third field or column. Let's say using the built-in variables to display line number, you can do something like NR, and it will print the line number. And again, you can move the columns around, so I can make it like this, right? Now you can see the power of, let's say, oh, I want all the URLs in front, so maybe I would, how do I get the last field? So last field is denoted by NF. So let's say I want to put the URLs in front, so I will do something like this, right? Or no, that's not the URL, sorry. I think it because I have some numbers there. $4. Yep, let's see. Print. You can try to print the second by row. Let's say I want to print. Let's see if this works though. Print to this one. Oh, it grabs the second field only. Why did it say row here? That's wrong. Let's try to use a conditional if this works. How does it know to separate by a space? Is it default? Yes. Tabs or spaces need no. Regex, yes, that's the also resource that I use and append later. Okay. Let's try if this even works. Let's add a conditional. If the length, well, let's say first column, I'm just gonna copy this code. Let's check if it works though. Max equals the length. If it works, I'll go ahead and explain afterwards. And print max. And syntax error somewhere along the lines. If okay. Put one. Okay. Okay. Before that, let me double check before I try explaining that one. And let me do another quick check. If I do both zeros. Okay. So with this program, basically what this command does is, I would like to find the length of the longest line in the present in the file. Longest line. Okay. So I would first use awk, and then to basically do my program, I would first do a single quotes and close them in single quotes, and as well as my first code block, you would say, is have an open and ending curly brace. And then what I want to do is basically create a conditional statement. So if and else, like if this, then this. So my condition basically, if the length of the line is greater than the max, this is just a variable. then let's update the max variable with that length. And then it will keep doing that for all of the lines. And then once it's done, it's going to end and print the max, which it will keep finding, which is 212. And then let's see if we can do it the other way around. Let's see, something like this. Let's see if I'm doing this logic correctly. And that's none. And how about the, let's see, count the lines in the file. So you can also count the lines in the file, awk, and then you open up with 2 single quotes and just use the end and print nr. So I have 339 lines. Let's see. So what if I want to find a string in a column? Again, let's check first this one. So let's say I want to search in the second column. Let's say I want to search for maximum for some reason. So I would do awk and close that by single quotes, the code blocks that you want. F column 2, if, sorry, then your condition should be enclosed with parentheses. Code block, column 2 is equals is basically just match, maximum. And then I want to print, let's say I want to print that one as well. Let's see if that works. And basically that checks all the lines in the second column with the word maximum. I can basically print other stuff as well. Let's say I just want to print the first column or all the lines with 0, or maybe the fourth 5. Let's see. NF. Okay, so NF is basically the number of words, because this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that makes sense. Okay. How about if I put the $sign here? There you go. So that prints the last line. Okay. So with awk, there's tons of way that you can use it, and I would keep saying this throughout the day that Grep, awk, and sed is a tool that you might want to invest more time to learn about, so that when you encountered something like a code block, you kind of at least understand how it will work or what it would output to. Like a good example is they can throw you a problem. Let's say, look at a log file. I think I've encountered that problem. They would throw you a log file and they would say, okay, which awk command or whatever sed command would basically output this one. And let's say in the raw file, you only have a small case MAR, which denotes for March, right? So if you see someone using a capital MAR, that should be a wrong pattern to search. However, if you if one of the choices gives you an option of, let's say, -I, which is ignore case, that command should work. So things like that. Let's see. Print any non-empty line if present. Print non-empty line. So we can awk. Put things together with nf. Let's say 0. So it basically just prints all non-empty lines. We can also print lines with more than 10 characters, or let's say more than 200 characters. Let's do something like that. So awk again and use the length. Length is basically a built-in function. And then the line is $0. You want to check a line. Just so you know, when I say a line, to give an example, let's see, just to make sure there's no confusion about that. So this is a line. This is a line. And let's see if I have a paragraph here. Ooh. Maybe I think this might be a line. No, this is a line. So a line would look something like this one. This is one line, I believe. Yep. Question. So yeah, sed uses regular expression and awk uses awk. Sed yes uses regular expressions. Awk uses the awk programming language, and I think you can use regular expressions. Yes, you can use regex with awk. Okay. Then let's move on first with this one. So length of a line, say greater than 100, and supply that with the file that we want to look at. As you can see, it looks like this, and basically searches for printing lines with more than 10 characters, not words, more than 10 characters. So we can push that to maybe 200 characters. And you can do that the other way around. Let's say less than 10 characters. Okay. Print the lines that have at least less than 10 characters. Let's see about this example that it shows you that you can basically do a for loop. Let's try that. Okay, awk, begin. Okay, so start with awk and single quotes and put your code block. Start with, let's say, begin. See if this works. For I equals 1, semicolon, I less than or equal to 6, I plus plus, close that one, print square of comma I is comma I times I, semicolon. All right. So to start with, you need the begin. It's a keyword basically that you have to use. Because let's see if we can use it without. Don't think we can Nope, can't use it. Okay. And then after the begin keyword, you basically want to open up a curly brace for your code block. Okay. Then now you want to create this is called a for loop. Okay. The for loop, we have the first value that we have, which is assigned to a variable called I. So I would have a value of 1. Okay. And what it says, we start at I with the value of 1. And if the value of I is less than or equal to 6, keep looping. This is called the loop condition. It would keep looping. And this is basically a shorthand notation to say that after each loop, please increase I by 1. Okay, so without doing the print stuff first, we can say that the first loop, the first time it would go inside of the loop, I is 1. And then once it reaches the end, it would now add 1. It would come again from the top and come inside. And I now is with a value of 2. We'll try to evaluate, is I less than or equal to 6? Yes. And then plus 1, it becomes 3, goes up, goes down again. Is 3 less than or equals 6? Yes. Plus again becomes 4. Is 4 less than or equals 6? Yes. Plus 1 becomes 5. Goes up, goes here again. 6 still satisfy the condition. 6 plus 1 becomes 7 and comes here. Is 7 less than or equal to 6? No, it now ends. It will jump out of this code block. Now, to incorporate this one now, so we start at the value of 1 and we go inside, and in this case, in the next fields or next column. And this one would basically say that I would print a square off, which is this one. As you can see, printed 6 times as well. And I would also print after a space is I, the value of I, which is, we said 1, 2, 3, 4, 5, 6. Okay. Yeah, actually, I didn't expect that awk has this actually, because last time I didn't really study awk a lot, just regex. But I won't go deeper than this. Maybe just this simple for loop and if, and then move on. But yes, Linux Plus would cover coding concepts like this for sure. Yes, like the basic coding stuff, especially when we go to Bash. And then just carrying on, and again, these are field 1 to be printed, field 2, field 3, field 4, or column 1, column 2, column 3, column 4, which is this one, 1, 2, 1, 2, 3, 4, and 5, sorry. And the last one, basically, whatever the value of I, multiply it with the value of the I as well. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36. Okay. Don't worry, the basic programming would come later on as well. And it would not go as hard as the algorithms and data structures. It's just simple if else. Regex would be the one that would be painful as well. Because at least this one, once you do some of it, you'll remember it. With regex, it's basically a bunch of symbols that you really have to somehow memorize. And then once you memorize it, it's basically easier. Okay, so this is awk. And sed is basically a stream editor used to modify text files according to various parameters and can be used for global search and replace action. Okay. So here's an example of a sed command. you use the sed keyword, and then you want to use the path or address and the action that you want in the file to modify. Okay, in this case, let's check the man pages of sed. See down there, wow, it's too long. D, delete the pattern and space and start the next cycle. Oh, cool. File contents after the action. Let's just go ahead and try that and see what happens. So it says here we can do sed, and this one says address. Let's see. Let's just see first what it does. Let's just do, let's say, maximum. And then let's now see if we can grab maximum. I wonder what happened there. We still have that, so let's see, sed address. Let me quickly check a sed example. Here we go, sed. Oh, okay. Let's start with a simple substitution. Okay, let's grab this first. And let's say I want to sed. Then now you want to do S, then /. That would say I want to substitute the first string that I want. Let's say I want to change all the maximum to a lowercase maximum, and in that same file. Oh, so this is just outputting because I am not piping it yet. So let me just check. And let me just grep it afterwards because I haven't piped it yet. Grep, cmax. As you can see, it basically manipulated all of my, the word with capital M maximum, it changed to smaller case, right? And I just pipe it to search for that once that output was generated, the standard output. But I would say that we can basically append the whole one to change it. And that is a redirection operator. The greater than, it means whatever the output is, overwrite everything in the same file name. And let's see if I grab that. And looks like I deleted it. Yep, it looks like I deleted it somehow. Totally fine. I can just copy that again. Why did it delete that? Okay, that was weird. Okay, so that didn't work for me. How about just appending? Whoops. How about let's use T instead? Okay, so okay, that works. So what I did instead, because somehow did not, I was expecting that the changes with the new output would overwrite in the same file, but that overwrite and remove everything. So what I did instead is the T command. So whatever the output is, show that in my command line interface, and as well as write it to the readme to the same file. And now when I grep that, yes, I all have the lowercase maximum, and I should not get any uppercase M. Okay, so we've gone over 5 minutes, so we'll give you until 50 minutes, 10:05 a.m. PST, and we'll try to talk more about regex. And just remember, guys, you do have a 11:30 meeting with Amaris, so I'll be giving you 30 minutes of the class time for that meeting. So 11:30 to 12 would be with Amaris, and then jump back 1 p.m. later. So be back. Send with an argument doesn't append the file automatically. Yes. Okay. Let me check where's the slides. Yeah, let's quickly go over the slides and then just cap it off with regex. Just to check if we covered some of the concepts that we haven't. So, options with Z said is you can delete lines matching the pattern and print only lines containing pattern. Let's try the option with the Z. So let's see if we can go back here. Let's say I want to do D. I think we can do something like this. Put it at the end, I think. And we should not be able to see anything. Great. So if we cat the whole readme.md python, oh, it deleted everything again. I must have used it the wrong way. The option said. Example. And let's do delete. Oh wait, I think no. Delete the pattern space. Again, man said. Sorry, delete again. Delete. delete pattern instead. That should have worked. Let me just copy that again quickly. This. I just not use the CP, right? Am I doing that one? And then okay. Let's try that again. I still didn't understand that one, why that happened. So sed, open up with single quotes, and you want to do pattern matching. Let's say max C, and then say this one, moon, or let's say the maximum, and then D, and supply that with the filing that we want. And that's the output, but I still have the maximum there. Lines ending with, oh, ending. So let's do starting with. Okay, let's just grab that so we don't delete the file first. And maximum, let's do the maximum, the other end. Interesting. Let's go back, delete. Beginning, sorry, beginning character. Syntax for beginning character is basically, I think it says this one. Yeah, it still didn't delete that one. Weird. It's super weird, super weird. Anyways, let's head back first with the lecture and we'll figure out it later. So you do have N and P, print only lines command. S, we used this earlier, substitute first occurrence of a string file. That one worked. And then what we use is something like this one, which is basically S and then / the pattern that we want to find and the pattern that we want to replace it with. Okay, that's the S, substitute S and G. Globally substitute original string with replacement string for each occurrence. Okay, S is only first occurrence, SG is global. Maybe that was why. So let's try this first. Substitute everything with that one. Okay. How about if we now try deleting again? Let's try to delete again. Sed the upper caret max mum or maximum or just this one. How about this one? And then following. No. Wrong. duplicate. We deleted that one for sure. So we should no longer find that anywhere if we scroll. Yep, it deleted somewhere here actually. This one. This has this maximum something, maximum subarray, whatever. And now we can even use diff now to check the differences. So we'll check with first the original one that we have and the one that we copied, which is located here. And now it would say that, let's see. Let's see if we can grab that. Yep. So as you can see, less than symbol, because the original file, which is the first file, which is denoted by the less than symbol, it has the maximum. Okay. And if we can scroll it down, let's see. Yeah, so as you can see, a lot of this, because I know we only removed this one, but it might have moved things around, you know, or might have deleted the whole section. So that's why it's saying that, hey, in the first file we have these, and we don't have a greater than symbol, because again, whoa, we didn't have a greater than symbol. What did I just do? What the hell? Oh boy. I just pressed something. Yep, so we didn't have the greater than symbol because in the second file we deleted stuff. So we don't have anything new to compare it with the first file. Okay, moving on. ln command is used to create a link to a file name in one directory. Link points to the file in another directory target. Link doesn't contain data, only reference to target. Changes link to link reflect in the target. If you don't specify a link name, it will be created in the current directory. And basically, it's what we've shown you before. Let's see. And a link would be denoted by this one, the arrowhead. So basically, when you, let's say, edit this one, you're basically editing this file instead. Okay. Let's see if we can try to use an ln command, but before that, there's types of links. You can use ln to create hard or symbolic links, and it's a feature for file systems like ext2, 3, and 4, and xfs for Red Hat. Hard links applies to files only and not directories. File data has more than one location on file system. If main file is deleted, data will still be available in link. Okay, can be created between files on different file systems, whereas in symbolic links can be created between two file systems. If the main directory is deleted, content is not lost, also known as soft links. Okay, let's see. ln command Linux. Let's do command ln make links, option the target, backup, any arguments. Oh, interesting. Symbolic. Okay, so by default, we're making hard links. Let's quickly do if we can use that. Let's say touch original.txt and touch link. No. Let's do ln. Do we have to supply it though? Target building. Second form creates a link. Target link name. Target link name in the link. Just quickly double check that. Source file, target file, source file, target file. So we have source file. Okay. Source file, target file. And type in there, link text. Okay, so you should create a new one. So let's see. If we do echo append link text. I'm just not sure first. Let's see this. Oh, here we go. So what happened here is basically I just updated the link.txt and it updated my original.txt. So I did not really edit. So the link.txt, think of it, it's like when I open it and edit, I'm not really editing the link.txt. It was pointing me to original.txt and letting me edit there and save. And that's why when I basically did a hi, echo hi, and append, meaning add to link.txt, what it does, it really points to original.txt and I've saved there. And once I do concatenate link.txt, it does the same. It goes to the original.txt to open that, right? And I guess the question of Bo and Alex, why can you still see the file if the original is deleted then? Yeah, so that was from the definition. And let's see how it looks like when we delete the original. And now we cat the link text. So it does store, so it's weird. I know it's not a copy, but it looks like if main file is deleted, data will still be available in link. Right? So we could investigate further, but from this, we can maybe assume that maybe when we invoke a delete command, it will make the file available to the link text, or maybe it did copy, right? Soft link is like a shortcut. Yep. Let's see. How about if you want to create a symbolic link? Okay, with -s. And let's try to do a symbolic link. Let's do another hard link, and this time with a verbose option. So I'll add V for verbose. Let's create another original file, sorry. Touch original txt, ln verbose option, original source file, and link 2. Let's do 2. So link, as you can see, it has that arrowhead. Link underscore 2.txt is now pointing to original.txt. And if we want to say, hey, and go back to the txt. tat.txt, and okay. And now what if we edit the original.txt? Well, let's find out. Ho, 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 ho. Original. Let's cat this one. So I guess it points both going to that and going to that one, back and forth, I guess. So that's hard link. Let's try to do symbolic links. Let's say we create, let's do ln -v. I want verbose, and let's make it symbolic. Original and link 3.txt. Okay, let's see how it looks like now in ls. So as you can see, a symbolic link, which we usually see when we do as ls-al, all in long format, it's denoted with a highlighted light blue. And let's now check how it looks like. So, okay, it did have that one. And just to verify, oops. Okay, let's try editing first in the link _3. 344 link _3. Let's check this one. Yes. And this one, yes. How about the other way around? Echo other way original. It does have that one. It does have that one as well. Now the next thing we want to test. A while ago with ln without any option, which is a hard link, we did not really. Was that a hard link? Double check. Yes, hard link. When we deleted that one, the original file, the link file still existed. How about now? So again, we have a symbolic link with link _3 text. Let's delete the original text. And let's see if we'll still have those. Oh, so look at that. It does show differently. It now shows a red text and a highlighted red text. Let's see if we can even look at that one. Ooh, no such file or directory. So that's a symbolic link. So if I deleted this CentOS release, the system release you won't be able to have anything with that one again. So this is like the real pointer, and the hard link, think of it's like your for the lack of a better term, maybe like a pointing / backup / copy, just to differentiate between them. So again, the symbolic link is also known as a soft link, and I guess someone mentioned it. Soft link is kind of like the shortcut, correct? Because remember in your Windows or Mac OS, when you do create a shortcut icon, if you delete the original where the path is located or the app is located, that shortcut function or shortcut icon won't work anymore. Say that you are a systems admin for operations department that wants to be able to read human resources file on personal time off Instead of having to go through all the trouble creating permissions or having to copy over the personal time off every time someone makes changes, you can create a symbolic link where a file that operation has access to simply points to that HR file. Yes, nice, nice, nice scenario. Yeah. And in terms of the Linux environment, like symbolic links are used so that you don't really have to go deeper. Let's say sometimes it's located somewhere nested, like somewhere subdirectory, and maybe in a different folder. But if it makes sense to be, let's say, system release should also be shown here, right, in the /etc. So you may want to add it there. Let's see if we can check more of those. So even bin /bin is basically located in user bin. Oops, not that one. Yep, so load those. So this one kind of helps people to say that, oh, I have bin folder, instead of like them going inside of the user live 364. Okay. And I guess it's time for the concept tests. If we are ready, this is going to be very quick later on. So I'll give the floor to the TAs. Thank you very much. Just don't forget to unmute if you're muted. Alex said there's no sound, so you might want to check your sound. Device settings, and maybe just toggle it. Ron, can you check your sound? Say hello. No, we can't hear you. Oh, can you guys hear him, or is it me that I can't hear him? Because my headset is funky. Also, no one can hear him, I guess. Ron, we can't hear you. I guess if it doesn't work, you guys need to learn how to lip read.
How about now? Can you hear me?
Loud and clear.
Oh, great. Wow, apparently some problem with my headset. Sorry about that. Yeah, I had some problem with the pool, but now it's finally in the chat. So yeah, we can start. I'm gonna get control of the screen here. So can you see my presentation right now?
Yes. Yep.
Great. All right. So the question is, how do you close Vim file without saving any changes and any changes that you've made on it? I put the full option here, full options, and the pool it's a little. I had to shorten it because it was not working, but yeah, you'll be able to identify the correct answer. This question, this content was presented yesterday, so give you guys a little bit more time. One more to go. Okay, I think perfect. We just received the last one. I'm gonna close this pool. And the answer is letter A. You need to press ask to enter the command mode and then enter column Q and interrogation exclamation mark. So with this command, you will ignore the changes made in the document and exit. Second option, hit I, will cause the editor to enter into the insert mode. So it's used to edit, not to quit without saving. And the last option is the option when you actually want to save the change made. I put the references in the book of each one of this content. And now we're going to move to the second question. Smita, if you may please send it to us.
Yes, Rowan, done.
Thank you. Okay, so about the results of the first question, most of people got it right. First option. So back to the current question. Can be used to compare two files, file1.txt and file2.txt. We have three options there of a command that can be used to compare two files. And as a hint, this was presented by Clark today, the very first topic he presented.
I'm sorry, Rowan, but my question had 4 options. So you can probably just have a look on the poly before you present the correct answer to them.
Okay. Let me check here. Okay. Yeah. Smita included another option in the pool, which is not a problem. This is actually the original question that she put there. So we still have one option that is the correct one, and I think we can close the pool right now. We have 20 replies already. So yeah, let's move to the answer, which is number C, as you could see today. The first letter, seed, as Clark was explaining earlier today, the seed or string editor command is a program that can be used to modify text files. So it's not the best option to compare two files. The grep command is basically a search tool, also not a good option. And the diff command is the one that we can use to compare two text files. Clark performed a lot of examples and demonstrated quite well how can we compare two files. The extra option included, let me see the results here. Yeah, AW key. So it's also not the best option. AW key is used to, let me just check here to make sure that I'm gonna give the correct answer.
It's used for pattern matching, Ron.
Pattern matching, exactly.
Mm-hmm.
Is used for when you need to evaluate and match patterns. So again, not the best option to compare two files. It's more used to evaluate patterns in the file. Okay, so back to you, Clark.
Awesome, Ron. Thank you. It's now back to me. Let's use a few more remaining minutes. Hopefully get all off the slides and do more stuff. Skip this. Skip this. I want to organize your backup directory, create subdirectory, each one. Logs will cross multiple categories, create links instead of copies, easier to manage. Also create links from home directory to logs and backups for easy access. Moving on. Text streams. Sequence of lines of text that application can leverage to read from or write to a particular device or system component. Especially useful for creating logs or other text use case, basically. Enables app to interface with components like your CLI, which the commands you've been using for how many days now. Files, network sockets. Oh, sorry, no screen. Yahoo. So I was mumbling about this slide, which is, I said we just skip it because these are activities. And I was talking about text streams. Now here, it can hide components details from the app, Linux text stream types, standard input, output, and error. We've been doing the input and output as well, and some of the errors actually. Standard input is basically a text stream that acts as a source for command input. Type in your keyboard, and basically that's the input for graphical user interface, such as this one. I can click on stuff, and that's basically an input as well. Standard output, it's basically called std out as well. Very familiar to the C++ language or C. the output is basically directed to the CLI by default. So when you do echo something, echo type, that's the std in, and the output is basically the output. Standard error, print error messages to CLI by default, like permission denied, something like that. We can quickly check those. Example. For example, I want to ls or cat. Which part I can't ls? No. Ooh, colorful. Not that one. Oh, let's say user add, right? I can basically. No, I should talk about this, the redirection operators later first. But basically, that's a standard error, permission denied. And because it's 10:45, well, I'll give you guys your potty break, and let's be back at 11. And we'll have 30 minutes of lecture time. So potty breaks for those who haven't done potty breaks yet. See you. And topic now is input-output redirection, the process of accepting input from a source other than the keyboard and sending output to a destination other than the display device. You can basically bypass default devices when working with input-output, typically used to read input from files and send output to files, not output to CLI this time around. Uses the std in, std out, and std error. Okay, streams. Redirection operators. We've used this many times. The single greater than symbol redirect std output to a file. If you do echo, then greater than the file name, or echo supplied with a string greater than the file name, it will just keep overwriting that file. If you do have double greater than symbol, it will append at the end of the file. So it will just add at the end of the file. It will increase. 2, with a greater than symbol, it redirects standard error to a file and it will keep overwriting that file. Same goes with the double greater than symbol now. It will append std error to the end of the file. For the ampersand greater than, it would redirect both std out and std error to a file. So ampersand will give you the output, which you normally see, and also put that in a file. Less than is basically read the input rather than the keyboard or mouse. So input from a file, whatever, email, whatever. And then less than string is provide input data from current source, stopping at the line containing provided string, called here a document, called a here document. Yep. So let's quickly check those stuff. Start with the basic one, hello. Then what we want to do is basically operator h txt ch txt. If you do that again, it's the same. But if we now use a double greater than symbol, it will append. And let's do that again. It will append. And if you want to remove it or overwrite everything, just the single greater than symbol again. That's pretty straightforward. And now let's use the standard error to a file. I'll give an example. Let's say this one, user add, permission denied. But if I do user add, then put that in a 2, greater than symbol, and let's say error.txt. As you can see, I did not see the error output anymore. It just sends it to the file. And now, if I look at that, I basically store the error. Great. This is a good way to, again, show the errors if you can't screenshot, right? Just give this text file. And then, if we keep doing that, it's basically just going to overwrite the file. But if you want to keep adding same, let's say, different errors or same errors, use a double greater than symbol, appends to the end. And now you can see that. To append again. And then let's override that with the 1 greater than symbol. Okay, and now you're wondering, well, what if I want to enter this command? I want to basically redirect that, but I also want to show it in the CLI and not only store it. So the way you do that is basically user add, let's say that's a command you want, and now you use the ampersand and greater than, and let's create a new file called error2.txt. It will output the CLI, the command line interface, as a standard output, and also store that in the error2.txt file, which it did not. Hooray, hooray! It should, but it did not. But at least we should be able to see that. Yep. For some reason, it's not showing, but it should be fine. I just try to remember the difference. It should work in some cases. Read input. Let's see if I do have an example here in the slides first. So this is the piping. Let's see, read input example. Let's quickly go to the document, CompTIA. Open that quickly. Yes, so you basically use it like, let's say you mail and you use, let's say, a email address. Just to show it, it's also in the document. It would look like something like this, but I don't have it. I don't have the mail server to do that, something like that. Okay, so the myletter.txt file will be taken as the input and attach it to the email message. So when I was trying to study it also with a friend, when you go further along, you would tend to forget which less than or greater than symbol you're going to use. But the easiest way to say it is the Pac-Man. Wherever the angle is opening up, it's basically grabbing that and putting that to the other side. So if you have a less than, it's kind of eating up the right side and trying to put it on the left side, right, in the stomach. If it's a greater than, again, like this one, any greater than, it's going to basically eat up the left side and put it in the stomach on the left side, on the right side, right? So think of the Pac-Man. I guess that would kind of solidify that it would get from the left or get from the right first. Let's see. The here document is basically something like this. Let me just show you this one. So basically with this one, you can provide a bunch of lines and use the input, let's say, to the cat command, right? The text for the cat command. So we can quickly check that. So let's end the file EOF. This is so any string. So let's first use this and A, Jude, and then EOF. So once it sees an EOF, it will basically stop there. So I can choose any character that I want. Let's say I would say Beatles. Hey, Jude. And when I say Beatles again, it will basically stop there. Okay, so your first characters that a string of characters you put will be basically your pattern that would end it, right? And yep, so that's how you can use it. Let's now move on to piping. Piping is very important. Wouldn't you need to T sudo? Yeah. Okay. I'll try to get back there and do T instead. But that might involve piping. So maybe it's for this one, right? Because kind of don't know how to see T. Nah. How about nah. I don't know how to combine those for now. So we can just look later. So let's go and move ahead with piping. Process of combining standard input-output streams of commands. Standard output of one command is used as an input for the other command. Okay, output format of first command should be compatible with second. As you can see, a pipe operator is used. Input goes output. So like we've used many times, let's say we list everything in long format, and let's say we have like thousands of files and directories. We just want to, let's say, grep the audit folder or audit directory or file. So you would want to use the grep to filter. Xargs reads stdin input and execute commands for each argument provided. Arguments must be separated by blanks or spaces. Pipe makes output of first command the input for second command, commonly used with find command, operate on each result of file directory search. So you can do something like this, find in your home/home/username, which is the tilde, then dash type to specify the type that you want. F is file, dash name, what file that you want to search for. With the wildcard, it says any beginning characters and ending with .txt, and make sure to enclose that in a double quotes. And now once it does that search, we now want to do a grep, a pipe. So let's say it will generate a lot of files like 1 to 10, but I want to pipe it and use it as an xargs chmod 775. It means that, hey, can you filter all the files that were outputted in the CLI to filter it with the chmod 775, which is, remember, 775 is user, group, others. 7 is 4217 total. 421, add them together. 7 is sum. This is 4 and 1, which is 5. Okay. T, I'm showing you earlier, it basically reads stdin and output to CLI and copies output to specified file. You can verify command output and now store it in a file for later. -A option appends to file instead of overwriting it. Don't need to show that. I've shown it earlier. Dev.null, think of this as the black hole, right? Everything that you send towards dev.null goes to nothingness, okay? That's the black hole. Also called the null device. You can redirect output to this file to confirm output was successful and not actually write data. Useful for testing commands, scripts, etc. Also useful for suppressing errors info in commands. So let's say you want to redirect output to dev.null file, right? So let's say you do want to, for some reason you want to use this and you just want to test it, right? And instead of creating a file, you can just put dev.null, right? So dev.null is very useful if you need to redirect to something, but you don't want to store it anyway. So dev.null is a good way to use it. Terminal redirection. A running process can be controlled by a terminal. Multiple terminals can run at once. Each terminal is assigned an identifier. Usual format is /dev/tty and the number. You can redirect std in and std out to controlling terminals. Reference is -dev-tty number, useful for redirecting text streams between processes. Activity, skipping that. Skip this as well. And reflective questions. Let's use the remaining time to now talk about regex. Even though we don't need to go down to the commands, we can basically use Juan's regex online, because most of us does use that. It's basically easier way to learn. So if you're learning regex, this should be again, I'll post this. This is one of the website, or maybe just stick to this one to really learn regex, because it not only helps you with the documentation, it also helps you match everything right away. So we can first look at where's that regex reference, right? So without looking at the left side first, sorry, we can jump ahead with this one. So without looking at anything first, you can see A-Z, right? So it means that you'll look for alphabet characters that matches the range A to Z. Let's just remove this one first. Maybe that one. Yep. So with this alone, it would match everything that has a capital letter A to Z, right? And in this case around, you start the regular expression with the / and end it with the / again. And the dash and the G is just basically the global search. I don't know if we can delete that here, but the global search means that find all occurrences, right? If you don't have that /G, it would just find the first capital alphabet that it can find and stop there, okay? The parentheses is basically the capturing group, right? So I like this so much because when you hover over the symbols or whatnot, it basically gives you an information. And now you want to use the character set, which now this is the range that you want, A to Z, and it's case sensitive, and it search for everything. So we can also do small case A to Z, and it matches every character that you see, right? If we go back quickly, if you do a /, it basically does additional stuff. So a /W, it means you would match words with those. But you want to do the plus. That's the correct one. Match one or more of the preceding token. So match all the words that would at least have a capital A to Z alphabet. So this is one of the first basic character set and word that you want to use. So please, again, please save this link. This is super important in learning the regex. And then negated set is the other way around. So if I don't want to see any capital letters, I would do a caret sign. Nope. Maybe put it out here. Nope. Let's see. Let's put A. No. A to Z. Let's see. Negated set. Something like this. A, I, O, U. And let's just remove the word for now. So, wow, this is messy. This is super messy. I don't like that. So this one, an example of range first. Let's go back to the range. Let's remove this, I guess. It will only match G to S, all right? A dot matches any characters except line breaks. No, not that one. Maybe this one? Yep. So it did not capture the line breaks, which is this one, and this one, and this one. Negated set. Let's see. Let's try the negated set again. So let's say I don't want any vowels. I do A, E, I, O, U. As you can see, the vowels are no longer included. Let's say I don't want the word maybe was. Nope, that's the wrong way to do that. Not a word. So you can just totally remove this. How about if we do W? Sorry, backslash, backslash, W. So find all the words. The spaces were not included. And if you want the opposite, the capital letter would basically find those that are not a word. Digit is basically a D. There's nothing here. Let's put some numbers. If you don't want to find the digit in the other way around, basically do a capital D. White space. That one. And not a white space. That one. Substitution is very helpful. Let me go back here. I think I created some simple scripts before to change some stuff. Repository. What was it? Space to underscore. No, I was doing TR here. Sorry, never mind. That's not a. Yeah, let's find that. Substitute space to underscore, because this might be something that you'd like to use or try out even in your own Linux or Mac OS. So you can easily search files. So you might want to replace everything that has a space with underscore. So let's see. No, let's do regex. So it shows you the regex pattern. Just so you know, the regex, you can use it in most programming language. It would have the same. So as you can see, it's something like this, blank, and then put that one there. But let's be more specific. Space to underscore regex Linux. I believe a lot of people would look for this one. Regex said. Let's see. Let's see. Substitute. Let's do substitution. Match. Show capture before match. Maybe we can quickly try that out. And here, we were doing something a while ago. I think that was a regex as well. Like this one. Okay, how about if we just do something like this? I know this is not file names, but let's just see. Oops. Yeah, so as you can see, this should be a space, because if I just do cat readme.py, right? See, it doesn't have underscores. Let's try everything though. How about if we put maybe a plus here, or all occurrence. All occurrence, maybe it's faster. Substitute regex dollars. Maybe that one. Nope. So let's see if we can use it here. Match. Let's see. There are examples here. This reference community patterns. Ooh, cool. Helpful as well for, yeah, Bailing 5. I know. Yep. I'll just do 2 more minutes. For example, I think this one. So I remember the last cohort when they were reporting about regex. They do use they try to use the regex that are basically that you can use, which is this one. You can easily just dissect it. Password validation. So I guess this is something new that I didn't see before. Community submissions. The easiest one, I think, phone number to understand. So I guess I would let you guys look at this, and if you guys have any questions, basically we can have a discussion tomorrow's lecture. When we start, I'll ask if you guys want to open up the regex topic, because you guys can share stuff as well during that time, because this is important. Again, I saw this in the exam. I'm not really great at regex as well, because even though I've used it, not a lot, not extensively, but I've used it, I still forget it just because of the weird patterns. And it does show in the exam. So I'll let you guys off now because you guys have a meeting. So have a wonderful meeting with Amarius, and guys, just don't forget to be back at 1 p.m. PST. Shoot us any questions if you have. Thank you for this morning participation, and I'll see you guys around.